Hello, so today we're going to be discussing the anatomy of a sound beam. There are five regions that make up the anatomy of a sound beam, and those regions are focus, near zone, far zone, focal zone, and focal length. Focus or focal point is the location where the beam is the narrowest. Then you have near zone or Fresnel zone, which is the region from the transducer to the focal point. In this zone, um, the beam converges or narrows as it gets closer to the focal point. Then you have far zone or Fraunhofer zone, which is the region from the transducer and then it from the transducer and beyond. It basically extends. In this zone, um, the beam diverges or widens as it goes deeper into the body. And it also becomes one half wider than the transducer. Then you have the focal zone, which houses the focus or focal point. And in this area, one half is located in the near zone and the other half is located in the far zone. This is a zone where you can create the most accurate images. Then you have focal length or focal depth or near zone length, and this is the distance from the transducer to the focal point. When it when it comes to the shape of a beam changing as it exits the transducer, the beam gradually gets bigger as it gets closer to the. I'm sorry, it gets smaller as it gradually moves towards the focal point. And then it gradually grows bigger as it gets deeper into the body. When it comes to the most high quality, accurate images, the focus and focal zone are the two areas or two regions that give you that um, will give you those images. The factors that influence focal depth in earlier transducers are the diameter of the transducer, the frequency, and the beam divergence. The diameter of the transducer uh, it, um, is simply a larger or large diameter um, that generally results in deeper focus, as well as high frequency produces shallower focus. Frequency, um, when it comes to frequency, higher frequencies tend to create a deeper focus, but it is counteracted by the need to control the need to control the focus through the diameter. And beam divergence is basically it showcases the important relationship between frequency and beam divergence. The higher the frequency, um, higher frequency causes less divergence in the far field. I'm sorry, in the far field, leading to a deeper focus. When it comes to lateral resolution, um, when a beam converges, the beam narrows until it reaches its smaller diameter, improving lateral resolution. And then as the beam diverges, it becomes wider in the far field, which decreases lateral resolution due to the widening of the beam.